Another common problem type used with systems of equations is dealing with mixtures. So looking at, for instance, a cleaner, we are trying to find the amount of each type of solution that would be combined together to create a brand of cleaner that has 20 gallons of a 40% acidic solution. Now these get a little bit difficult, and so what one option is to create a table to help you keep yourself organized. Again, our table will help us to get organized. So I will start my table knowing that I'm being asked about the total solution and also the percent solution for each of the different brands of cleaners. And I know that I know some information about the 25% solution, some about the 50% solution, and some about the total. So before I start filling in the table that it's going to help me create my equations, it's important that we always identify what our variables will stand for. So I'm going to say X is equal to the gallons of the 25% solution, and Y is equal to the gallons of 50% solution. Sorry about the bad handwriting. So now, looking at my total, remember if I'm looking at total gallons, I would say that I have X total gallons of the 25% solution, and I have Y total gallons of the 50% solution, and my total gallons of solution is 20. So now I have my first equation, X plus Y equals 20. My second has to do with the percent solution. So here I'm going to take the 25% solution times X, so that's 0.25X. I'm sorry, that's an X. And here I'm going to take the 0.5 times Y and make sure that that's 0.5 and not 0.05. 0.5 is 50%. And here I'm going to take the total, which is 20, times the 40% acidic solution, so 0.4 times 20, which is 8. So there are my two equations. And you can solve either by substitution or elimination. Honestly, it doesn't matter which way you choose to do it. My two equations are X plus Y equals 20 and 0.25X plus 0.5Y equals 8. I find it easiest on questions like this to take this equation and just rearrange it. So I'm just going to subtract the Y from each side and say that X is 20 minus Y. And now I'm going to take this equation, 0.25, and I'm replacing X with 20 minus Y, and then plus 0.5Y equals 8. I'm going to distribute, so 0.25 times 20 is 5, 0.25 times minus Y, minus 0.25Y. Everything else gets recopied. These two values on the left side of the equation are like terms, so I can combine them together. So I get 5 plus 0.25y equals 8. I'm going to subtract 5 from each side, so 0.25y equals 3, and then divide each side by 0.25 to end up with 12. Remember, that's one of the values, so now I'm going to say x plus y equals 20, but instead of y, I'm replacing it with 12, and I get x equals 8. And again, then you would write your sentence that says, I would have 8 gallons of 25% solution and 12 gallons of the 50% solution to produce 20 gallons of the 40% solution. Very similar question on this one. This one's dealing with chocolate, one of my favorite things. Again, I'm going to let X represent, in this case, the number of pounds of the $5 per pound chocolate, and Y represent the number of pounds of the $3 per pound chocolate. And again, you can create a table if you want, but you don't have to. The two things we know are the number of pounds and of course the cost. So that's going to represent my two equations. I've got the $5 chocolate and I've got the $3 chocolate and I've got the total. So for the number of pounds, I would say X plus Y equals 20 pounds. For the cost of those, I would say that I would have to take 5 times X plus 3 times Y to get 20 pounds worth 450 per pound, so 20 times 4.5, also known as 90. Again, choose whichever method that you would like to solve. I'm going to choose to take that first equation, all times -3, so that I can eliminate my y's, which would give me -3x minus 3y equals -60, and recopy 5x plus 3y equals 90. That gives me 2x equals 30, so x is 15. Plug the 15 back in to either equation. I'm choosing the easier of the two. To find that y is 5, and again I would write a sentence that I would need 15 pounds of the $5 per pound chocolate and 5 pounds of the 3 per pound chocolate to make 20 pounds of a $4.50 per pound chocolate. This last one is similar to the first example that we went through together. Again, I'm going to let x represent the number of ounces of the 50% solution and y to represent the number of ounces of the, scratch. Our last example is very similar to our first example. Again, try this one on your own, then press play. A pharmacist needs 8 ounces of a 50% solution, and he has or she has a 60% solution and a 20% solution to deal with. So I'm going to let x represent the 60% solution ounces, and I'm going to let y represent the 20% solution ounces used. And then again, I can certainly make a table to help me. I would know ounces, and I would also know the percent solution or the acidity of the solution. And I've got a 60% and a 20% and then a total. So for ounces total, I would have x plus y equals 8 ounces. And for the percent solution, that's 0.6 times x plus 0.2 times y equals the solution of 8 times 0.5, or 4. Again, you can choose whichever method that you want. I've solved the other ones using elimination. I'm going to choose substitution on this one. So I'm going to call this x equals 8 minus y and plug it in for x. So 0.6 times 8 minus y plus 0.2y equals 4. I'm going to distribute that 0.6, combine my like terms on the left side of my equation. Everything else stays the same. I'm going to subtract 4.8 from each side, and I'm running out of room, so negative 0.4y equals negative 0.8. I divide each side to find y is 2, and then I'm going to plug it back into my original equation, so x plus y of 2 equals 8, so x must be 6. Again, I would write a sentence that said I would use 6 ounces of the 60% solution and 2 ounces of the 20% solution.